Let us then consider this next question, right? Two lamps of resistance 4 kilo ohms each are in series. These lamps were then connected in parallel to a lamp of resistance 1 kilo ohm, which was also in parallel to a fourth lamp of resistance 10 kilo ohms. The whole arrangement was connected to a battery of 10 volts. Find the I, voltage in each lamp, II, current in the 1 kilo ohm lamp. How do we approach this question? We're going to make a sketch of what the circuit looks like. However, I would like to say that if one actually understands this, analysis on the board here, given us question, we can actually solve without even giving the sketch for this particular question. But for the purpose of clarity, I would like us to make a sketch of it. We have two lamps of resistance 4 kilo ohms each. Now, these two lamps were connected in series. You would recall in the previous question number 2, I stated that when problems of this kind is given, in sketching the circuit, we arrange or walk through the resistors, arranging them towards the voltage, the cell, the voltage source given. Are you following, right? So it simply means we're going to start our arrangement of resistors from this while moving towards the part where we would like to fix this 10 voltage battery. Now I would like the 10 volt battery to be on my right hand side. So if I am sketching this circuit, starting with the 4 kilo ohm resistance lamp, each of them, there are two there, then I expect to get, okay, let's say something like this. Expect to get something like this. Let me use blue marker for the sketch. Okay, so it's going to be something of this form. This, let's say it's the first 4 kilo ohm resistance lamp, and then the next, I'm going to fix it here. Alright, so these two resistance lamps that are in series were then connected to another lamp. Alright, the value of that, the resistance of that lamp is 1 kilo ohms, and it's in parallel to these two. So I'm going to do something like this. It's in parallel to the two initial series resistance lamp. This 1 kilo ohm resistance lamp was again connected to another resistance lamp of 10 kilo ohms. So this goes this way, and I'm going to do this. Representing the 10 kilo ohms. Now this whole setup was now connected to a battery of value 10 volts. So I'm going to do this, and then put 10 volt value here. Alright, so you can see the first two resistance here are 4 kilo ohms, 4 kilo ohms. So we're going to have this 4 kilo ohms. Then this is 1 kilo ohm, 1 kilo ohm. Why this is 10 kilo ohms. So this is the sketch of what this circuit looks like. This is how the lamps were connected. Now the first part of the question, it is required that we determine the voltage in each lamp. The voltage in each lamp. Now, how do we handle this problem? Looking at the circuit here, the battery has a voltage of 10 volts. There is something we explained when we treated resistors arranged in parallel. We stated that they would have the same voltage. That simply means that for any resistor here in parallel with another one, they are going to have the same voltage. Now let us take a look at this battery. This battery is in parallel to this 10 kilo ohm resistance lamp. True or is that not true, right? This battery of 10 volts is in parallel to this resistance lamp of 10 kilo ohms. It simply means that this is going to have the same voltage value as this battery, because they are in parallel. Since this is the first resistance after this 10 volt battery, this is the first resistance you made. It simply means that this resistance is the internal resistance of this battery. That's just the analysis of it. Suppose this resistor was connected in series. If it was connected in series, then the value of the voltage will not be exactly the same as the 10 volt, because we know that series connected resistors, they reduce what? Voltage. Is that not so? Voltage divides, which leads to a reduction in the value of the voltage. But if the resistor is in parallel, just as we have in this case, it means that the voltage in this lamp is going to be the same voltage of the what? Battery. Simply because they are in what? Parallel. So I'm going to indicate that the V across the 10 kilo ohms resistance lamp is equal to 10 voltage. That's 10 volts. Alright, and I'll put answer. I will state the reason for that. So that this is because the 10 kilo ohm resistance lamp is in parallel to the battery of 10 volts. So it's clear, right? Okay, now let me do something before I proceed to the next one. We assume now that the voltage operating at this point is 10 volts. So let me say that I cancel this off. Let me say that I cut this off. Is that okay? It's gone. The voltage is 10 volts. It simply means that the voltage here is now supplying this resistance lamp. Are you following, right? This voltage here, which is 10 volts, is also supplying this 1 kilo ohm resistance lamp. Let me indicate this. This is 10 volts as well too, the resistance in this, 10 volts. Okay, now if that's the case, this 10 volts will be feeding this 1 kilo ohm resistance lamp. And you can see that this 1 kilo ohm resistance lamp is also in parallel with this. And because it is in parallel with this resistance lamp of 10 kilo ohms, it simply tells us that they have the same what? Voltage. So I'm going to write that voltage across the 1 kilo ohm resistance lamp is also equal to 10 volts. I'll also give my reason for that. The same reason we gave for the voltage across the 10 kilo ohm resistance lamp. So this is because the 1 kilo ohm resistance lamp, 1 kilo ohm resistance lamp is in parallel with the 10 kilo ohms resistance lamp. So because they are in parallel, simply means they're going to have the same voltage. Good. I would also do something here. We say this is 10 volts as well too. Then permit me to cancel this arm. So if the voltage operating at this point is also 10 volts, it simply means that that voltage which is operating at 10 volts is what is supplying the remaining two resistance lamp. His value is 4 kilo ohms and what? 4 kilo ohms. But this time around, take note of something. This resistance lamp of 4 kilo ohms and this one of 4 kilo ohms, they are in what? Series. And because they're in series, it means they will divide the voltage getting to them. The voltage value getting to them is 10 volts from here. Is that okay? So this 4 kilo ohms and this 4 kilo will reduce that voltage value. They will reduce that voltage value. But the point in this case is because both of them have the same value of resistance. It means that as they are sharing the voltage, you will have equal value of what? Voltage. But that voltage value will no longer be 10 volt, just like these two were. Is that okay? I stated the reason why these two have the same voltage as that of the source. Because this is parallel to this, the voltage will be the same. This 1 kilo ohm resistance lamp is also parallel to this 10 kilo ohm resistance lamp, hence will have the same voltage as it. I will take a short break. When I'm back, we'll use the voltage divider rule to obtain the voltage across each of these 4 kilo ohms resistance lamp. You are welcome from the short break. Before the break, we had obtained the value of the voltage in this 10 kilo ohm resistance lamp. We also did same for the voltage in this 1 kilo ohm resistance lamp, which I stated that because these resistors are in parallel with the source, the battery, directly in parallel, it means that you have the same voltage as that of the battery. We now want to determine the voltage value in this 4 kilo ohm resistance lamp as well as in this 4 kilo ohm resistance lamp because they are in series. I stated that we're going to use the concept of VDR to do that. At this point, permit me to redraw the equivalent circuit we have, for which we're going to use to determine the voltage in the resistance lamp of these 4 kilo ohm resistors. Is that okay? The sketch is going to be something like this. This is what we have at this point. It's what we have at this point. Okay, so we have this. Now I will put 10 volts here. This 10 volts, this 4 kilo ohms, and then this 4 kilo ohms. Alright, 4 kilo ohms. So you say this right? We're going to use the voltage divider rule now to obtain the voltage in each of these resistance lamps. Take note why this is 10 volts. Up to this point, the voltage in this 1 kilo ohm resistance lamp is 10 volts. And that voltage now would feed, alright, will supply the remaining resistance lamp here. So we're going to share that 10 volts value to this 4 kilo ohm resistance lamp. Using our VDR, now you recall, the Vdr formula is, if you have the voltage to be calculated across a particular resistor, it's going to be that same resistor divided by the sum of the resistors there. Then we're going to multiply by the total voltage. So if we apply it here, I chose to determine the voltage across this 4 kilo ohm resistor. Is that okay? So it's going to be V across the 4 kilo ohm resistance lamp will now be equal to the resistance of that lamp, which is 4, divided by the resistance of that lamp plus the resistance of any other lamp that shares the voltage with the one whose voltage you are looking for, which in this case is meant to be this. So this is going to be something like 4 plus 4. Then we're going to multiply this by the total voltage feeding them, which is 10. I hope you're following, right? Suppose this were to be 3 kilo ohms, and I'm calculating the voltage across this 4 kilo ohms. Then the formula will then be 4 all over 4 plus 3. Or if I'm calculating the voltage across this, supposing that this is 3 kilo ohms, then I'm going to say voltage across the 3 kilo ohms resistance lamp equal to 3 kilo ohm resistance lamp divided by 3 plus 4, then multiply by the source voltage. So that's what we do there. Let us see what this is going to give to us. If you work in this, we're going to get 4 over 8. 4 over 8 is 1/2. Of course, 1/2 multiplied by 10 will give us 5 kilo ohms, right? This is meant to be 5 voltage. 5 volts, is that okay? 5 volts. So this is the value of the voltage in this 4 kilo ohms resistance lamp. Like I stated, that same value would be what we have here. Does that make sense? So then to my conclusion here for the second one as well too. This is our answer. I said this is the same voltage. This is the same voltage in the second 4 kilo ohms, 4 kilo ohm resistance lamp. Is that okay? So no need of doing anything in that. But suppose this were to be 3 kilo ohms, like I said, and I have calculated the voltage in this 4 kilo ohm resistance lamp. Let's make an assumption on that. You can get your calculator and walk along. Let us say that this is 3 kilo ohms. If I'm calculating the voltage in this 4 kilo ohm resistance lamp, then this will be 4 over 4 plus 3. And if I do that, 4 divided by 4 plus 3, which is 7, and then you multiply by 10, that gave 5.714 approximately. Are you following, right? So if I want to get the voltage across the assumed 3 kilo ohm resistance now, it will now be the total voltage, which is 10 minus that 5.714, which if I seek for that, it just gave me 4.28. I hope it makes sense, right? The reason why I didn't bother myself calculating the voltage in this 4 kilo ohm resistance lamp again is because its resistance value and that of this is the same. So they will have the same value of voltage. So that's how we handle this problem in the voltage aspect. I'll go for a short break. When I'm back, we'll determine the current in the 1 kilo ohms resistance lamp. That will require that we make use of either the voltage divider rule or we can make use of Ohm's law. And of course, I guess I'm going to use Ohm's law so as to be fast in doing that. Alright, now let us conclude this question with the second part where we are to determine the current in the 1 kilo ohm lamp. There is II, current in the 1 kilo ohm lamp. We do not know. Take note, this 1 kilo ohm is the same as 1000 ohms. There's kilo there is 10 raised to the power 3, that's 1000. So we have to determine the current in this 1 kilo ohm lamp. Recall that I told you I'm going to use Ohm's law to get this current because of course we already know the value of the resistance. Is that okay? And we know the voltage in it. So we can actually use Ohm's law to obtain the value. Using Ohm's law, you know that current is equal to voltage divided by what? Resistance. So the current across the 1 kilo ohm resistance, will now be the voltage in it, which is 10 volts, divided by the resistance. This resistance, which is 1 kilo ohms, alright, is the same as 1 times 1000. I stated that already. Kilo is the same as 1000. So if you work in this, the current you're going to get is 0.01 ampere. So that's the value of the current you're going to get, 0.01 ampere. Answer. Now, you would also recall that I mentioned that if you use your CDR, that is current divider rule, you will still get the same result. Is that okay? But just for us to get our answer quickly, I've chosen to rely on Ohm's law since we know the value of the resistance and the voltage in it. However, I've been able to do some analysis on it using the current divider rule, and these are various values you are going to get if you use the current divider rule. Are you following, right? I'm going to write them on the board, notes. I'm going to write them on the board, notes, using CDR. Already in question number 1, we've already explained the concept of using current divider rule to obtain the current in a given resistive element in a series parallel network. So we can use that idea to do that. Now first, we get the total currents in this circuit. To obtain the total current, we have to get the total resistance. But this was what I did. I had to convert all the resistance values to ohms, from kilo ohms to ohms. Are you following, right? And then solved. Now in doing that, in the first case, the total value of the resistance you are going to get, because if you're using CDR, you need to know the total current in these circuits. So note, using CDR, you first obtain the total resistance, R total, and when I did that, actually it gave, I think, 816.33, alright, I think 339 ohms. That's what I obtained. And then from there, the total current in the circuit, of course, I had to use Ohm's law for that, which is total voltage divided by the total resistance. And this was what I obtained as the total current, 0.0122 ampere. I'm writing this on the board so you can use that CDR to confirm that you still get the same result. Is that okay for the current in this 1 kilo ohms resistance. Then after that, you need to know if the total current produced is 0.0122 ampere. Is that okay? You need to know the value that is going to flow through this 1 kilo ohms. And to do that, assume the current comes out here, I total. Are you following, right? It moves this way. Once it gets to this point, it will shear. I hope you know that it will shear. One will move in down to this 10 kilo ohms, the other will go this way. That one feeding this. On getting to this point, it will shear. Are you following, right? It will shear. One will go through this 1 kilo ohms and the other will move through this 4 kilo ohms lamp and this 4 kilo ohms resistance lamp. I hope you see the division, right? Now, when I worked on that, this is what I got. Using the CDR, the current that flowed through this 10 kilo ohm resistance gave this value. It gave 0. Okay, so let me indicate. The current that flowed through this 10 kilo ohm resistance gave 0.000996 ampere. That was the current that flowed through here. Now, if we know the current that entered through this 10 kilo ohm resistance out of the total, and the total is 0.0122, to know the one that will feed the remaining part of the circuit, you will subtract this 0.000996 that entered here, that branched into this part. You subtract that value from the total, which is going to be 0.0122 minus 0.000996 to get the value of current that will enter this arm from this loop to this way. Are you following, right? And when I did that, the current, I used the current that will be feeding 144 kilo ohm resistance. Okay, let me write 144 kilo ohm resistance. Alright. So the current feeding that part, when I actually did that, I obtained 0.0122 ampere. Is that okay? Now, from there, this current is the total current entering this part from here like this now. Are you following, right? So it's going to feed 1 kilo ohms, 4 kilo ohms, and this 4 kilo ohms. But at this point, that value of current 0.0122 will shear. So you still need to use CDR at this point, just like you use this to get the current that will enter here. Are you following? You still need to use CDR at this point. And when I did that, to get the current entering this 1 kilo ohms, of course, you need to get the total of this one, since these two resistors are sharing the current between these, okay? So when I worked on that using CDR, I got a current that is flowing through the 1 kilo ohm resistance lamp to be equal to 0.0099 ampere, which approximated to 0.01 ampere, exactly like what I obtained here. So having given you the part, you follow the CDR and values you likely get. Why not do that, alright? Use the principle of the CDR rule that I taught and explained using question number 1, and check how you can get these values. Once again, these were the things I obtained using CDR, and eventually it bounces back to the value I got using Ohm's law.